So question 1 asks us to find the critical numbers and then determine whether each critical number is a relative maximum or minimum or neither. And so the first step in these questions is that we're going to want to take the derivative and then find all those critical numbers. And then those critical numbers will determine the intervals upon which we need to check whether the derivative is positive or negative to see whether the function is increasing or decreasing. So to take the derivative of this, we're going to have to use product rule. So, right, we have two factors here. We're going to take the derivative of the first factor and then leave the second factor alone. So that the derivative of the first factor is -1. So that'll be -1 times x plus 1 squared plus 1 minus x. And we're going to use chain rule on the derivative of x plus 1 squared. So it's 1 minus x times 2 times x plus 1. If we expand this, we get -x squared plus 2x plus 1 plus 2 times 1 minus x squared, I believe. And this will yield -x squared minus 2x minus 1 plus 2 minus 2x squared equals -3x squared minus 2x plus 1. And then this is something that we're going to have to factor in order to find those critical numbers. So I'll factor by grouping. Okay, and so my critical numbers are going to be whenever this equals 0. And so that's either -3x plus 1 equals 0, which means x equals 1/3, or x equals -1. So two critical numbers. Okay, so that means I can divide the number line up like that. I'll have -1 here and 1/3. And so I know the derivative will equal 0 at those points. And so that tells me that I need to check within these three intervals here and see whether the derivative is positive or negative. And so where's the simplest form of the derivative? Probably be this, right? And so I could test this interval first. I'll test, what's the best way to write this out for you guys? I'll write it here. So the first interval is -infinity to -1. And so I'm going to test let's do a test of x equals -2, because that's within the interval, right? And so I just need to plug that into my derivative here and see whether the derivative is positive or negative. So f prime of -2 is going to be equal to 7 times -1, which is -7. So that tells me that this interval is decreasing. So I can put a minus here. From -1 to 1/3, a good test value would be x equals 0. If I plug that in, f prime of 0 is going to be 1 times 1. So that means f of x is increasing. Then if I test 1/3 to infinity, I could try out x equals 1. And then f prime of 1 is going to be equal to negative 2 times 2, which is negative 4. And so f of x is decreasing. Okay, so it's minus. So that tells me that x equals negative 1 is a minimum because it goes from minus to plus, right? So that means it's a dip. And then x equals 1/3 is a relative maximum because it goes from positive to negative in terms of its slope, and so it must be a mountain, a hump. Let's do b. Here we have f of x equals 2x plus 1 over x. And so the derivative is 2 minus 1 over x squared. Now, the goal is always to factor this as much as possible because that will give me the most information about critical points, because that'll tell me when everything is equal to 0. And so the best way to factor this is by first turning it into a single fraction. So this becomes 2x squared minus 1 over x squared. You can factor this in different ways. I'll probably factor this as root 2x minus 1 times root 2x plus 1, the difference of squares. And so we're going to have critical numbers of x equals negative root 2 over 2. That will make this equal to 0. And 0, because that makes the denominator 0, which makes the derivative undefined. Remember, the critical number is not only what makes the derivative 0, but also what makes the derivative undefined. Then we'll have positive root 2 over 2. So that means the number line will be divided up into 4 intervals. So we need to go ahead and test each of these intervals and see what they're doing. Let's test the first interval. Let's test x equals negative 1. F prime of negative 1. Where's the easiest way to plug this in? The easiest place to plug that in is probably all the way at the start, right? So f prime of negative 1 is going to yield 1. So that tells us that f is increasing. This is plus. For our next one, we can probably test negative 1/2 maybe. That's in between negative root 2 over 2 and 0. So if we tested negative 1/2, we get f prime of negative 1/2 is equal to negative 2, I think. The rest is the same, almost. Okay, so out of our critical points, x equals negative root 2 over 2 satisfies all of our criteria for being a relative maximum. Okay, remember what are the two criteria? First of all, f prime of x has to equal 0, and second of all, f prime has to go from positive to negative, and vice versa for relative minimums. It would go from negative to positive. But it's very important that f prime has to equal 0 in order for it to be a relative maximum. At the very least, the function has to be defined. I can think of one case where it actually doesn't equal 0, and that's for an absolute value function. But the function does have to be defined. And that's very important, and we'll see here, because for x equals 0, it is neither a relative maximum nor a relative minimum, because f0 undefined, right? It makes the denominator equal 0. And so this is neither. And for x equals positive root 2 over 2, we have a relative minimum. Okay, so if we were to sketch the graph, it would look like this. Yeah, like this. And so clearly at x equals 0, it's neither a minimum nor a maximum. It's not even defined there. But we're going to have one relative maximum and one relative minimum there. Let's do part C. Here we're going to have to use quotient rule. So we have low, b high. Minus high, d low, that's 1, over low squared. So it's going to come out to 2x squared minus 2 minus x squared plus 2x minus 1. We write the original. Original equation. It's going to be simplified as x squared plus 2x minus 3. Which we can factor x plus 3 times x minus 1 over x plus 1 squared. Okay? So we have three critical numbers here. So our C numbers are going to be x equals first negative 3. That makes the numerator 0, so the whole fraction and the whole derivative is 0. Then we have negative 1, makes the derivative undefined, and then positive 1 makes the derivative 0. So that splits up our number line into 4 intervals once again. Negative 3, negative 1, and then 1. Let's test all these intervals. Negative infinity to negative 3. Let's test x equals negative 4. All right, what is f prime of negative 4 going to be? If we plug that in, we're going to get, in the numerator, we have negative 1 times negative 5, so it's 5 over 9. That's positive, certainly. Increasing there. For negative 3 to negative 1. test x equals negative 2. And that means f prime of negative 2 is going to be 1 times negative 3 over 1. Okay. Looks good. And so my answers are going to be x equals negative 3 is a relative maximum because it goes from plus to minus. And also the function is defined at x equals negative 3, right? On the other hand, x equals negative 1 is undefined. The function is not defined there, nor is the derivative. And x equals 1 is going to be a relative minimum because it goes from minus to plus. And that's that. 2. Here we're talking about concavity, right? So remember, concave upward is like that, concave downward is like that. And to find that, we're going to have to look at the second derivative and do pretty much the same process. So for the first question, f of x equals x to the fourth minus 3x cubed. Let's calculate the second derivative. Take the derivative twice. And that's going to require us to factor this. And so here, there are two, not critical numbers, but they're going to be called points of inflection points. And so we're going to be looking at x equals 0 or positive 3/2. And so we need to check these three intervals that the number line is being split up into. And so for negative infinity to 0, we'll test x equals negative 1. That is going to make the derivative equal to 30. Second derivative, sorry. That's going to make the second derivative equal to 30. And so that means it's concave upward. So we have a plus here. And then from 0 to 3/2, let's test x equals 1. We are going to get negative 6. So it's minus. It's concave down. And from 3/2 to infinity, we'll test x equals 2. We should be getting 48 minus 36, which is 12. Positive. All right, so the answers are going to be negative 8, 0. It is going to be concave up. 0, negative 3/2 is going to be concave down. And then 3/2, infinity is going to be concave up. Part b. First derivative. And then second derivative. X cubed. All right, so where is that going to equal 0? Find that point of inflection. That's going to equal 0 when x equals 0. So that only splits up the number line into two different intervals. So let's check the first interval. Negative infinity to 0. Let's test x equals -1. F double prime of -1 is equal to -20. So it's concave down. For 0 to infinity, let's test x equals +1. F double prime of +1 is equal to 20. That's positive, so it's concave up. Let's do part C. This is not going to be very pleasant in terms of the derivatives. We'll try to slog our way through it. Keep simplifying this first. I regret assigning this question. Oh, good. It simplifies a little bit, at least. There's an easier way to solve this, but it's a bit tricky, so I don't want to show you. Okay, let me check my work. So we get this 4x over 3x squared plus 1 squared. And take the second derivative. Low d high minus high d low chain rule, right? There are different ways to simplify this. You could either factor out a 3x squared plus 1 first, or do something else. You could just expand the whole thing. I'll probably factor. cancel out that factor of 3x squared plus 1 from the numerator now. I should have done that earlier, shouldn't I have? 36x squared plus 4. And the bottom is cubed. And this we can continue to factor as negative 4 9x squared minus 1 give us a difference of squares. Let me use a computer just to make sure that this answer is correct. Good, I'm right. Okay, so f of f double prime of x equals 0 when x equals 1/3 or negative 1/3. And we never have to worry about the denominator equaling 0 because this is always positive, because x squared is always greater than or equal to 0, and we're just adding 1, right? So this is always a positive number in the denominator. All right, so we have 3 intervals, don't we? Negative 1/3, 1/3. And so let's test the first interval. Negative infinity to negative 1/3. So let's test x equals negative 1. F double prime of negative 1 is equal to, I'm going to plug it in here because that's probably the easiest. That is going to be equal to negative 32 over 64, which is negative half. So this will be minus. Is that correct? Should be right. Let's test the next interval, negative 1/3 to 1/3. Here we'll test x equals 0. That is going to give me 4. So we have a positive number here. Positive concavity. Then for the last one, 1/3 to infinity. I'll test x equals 1, and f double prime of 1 is equal to negative 32 over, right, same thing, negative half. That's minus. So after a lot of work, we find that this is concave down. This one is concave up. This one is concave down. That was pretty long.